All right, so what we have here is we have a graph of active clusters of woodpeckers. Okay, you can tell this data is a little bit old, man. My latest data point is 2000. I should probably fix that, huh? But anyway, this was actual data that I found, and this was clusters of woodpeckers in some park. Okay. In 1992, they had 22 active clusters, and then obviously it was growing slowly, okay? The one thing I did forget here, and I want you guys to do, is I want you to label these, so I should put years here, okay? And over here I should put active clusters. Okay. So now we have our scatter plot, and as you can see, there's a very tight correlation here. So our correlation coefficient for this problem would probably be very, 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 very close to 1. Okay, the R value here would probably be at least 0.9. Okay, approximately equal to 0.9. Okay, and that's the way most of these are going to be because the data that I found, they're pretty tightly correlated, okay? And obviously it's positive because it's going uphill. Now, here's what you have to do. We're talking about a regression line or line of best fit, okay? Regression line or line of best fit, okay? A regression line allows you to make predictions. So here's what we're going to do. I'm going to do my best to go through, get as close to as many points as I can and go through as many points as possible. Well, with this data, it's pretty easy. Obviously, you're going to see that I'm not going to go through all of them. I think I'll probably go about like that. Okay. Bam. All right. Now you'll notice I'm going through a bunch of these lines. Really, you only have to go through 2 of them, all right? But I'm actually going through 1, 2, 3, 4, 5. There's 2 that are above and there's 2 that are below, so I'd say that's a pretty good line. Now, if you go through more than 1, what you want to do is you want to identify the 2 that are furthest apart. So one more time, if you go through more than 2, you want to identify the 2 that are furthest apart. So I'm trying to draw a line that gets as close to as many points as possible, number 1. Number 2, I'm trying to split it. So I've got equal number of points above and below, okay? Number 3, the line has to go through at least 2 points. Well, in this case, of course, I went through 1, 2, 3, 4, 5 points. But if I go through more than 2, then I'm going to pick the 2 that are furthest apart. So what is this point? This point is the point 1993. Yeah, I'm just going to do it. 1993, 24. So I'm just going to actually go 93, 24. Okay. And then over here, I chose the point, what is that? 99. And 49, 99.45, is that right? Yeah, 99.45, okay. Okay, once I have those 2 points, now I'm ready to go. I can come up with an equation for this line. So here we go. We're gonna say, all right, slope equals, change in y, 45 minus 24, so that's my change in my y values, over 99 minus 93, which equals 21 over 6. 21 divided by 6, what is that, about 3.5? 3.5. Okay, there we have our slope. Now, the next thing I need my point slope form, which is what we've been discussing in the previous assignments last week. Y minus y sub 1 equals m times the quantity x minus x sub 1. Okay? Now we're going to plug that in. So at this point, I choose a point, and it doesn't matter which one you use. Believe it or not, it's going to turn out exactly the same. So I'm just going to choose this guy right here, 99.45. So here I go. Y minus 45 equals 3.5. Mr. Palin, you've always left that as a fraction, I know. But for this problem, and for most of these other problems, I think it's just going to be easier to get into a decimal. X minus 99. Okay, so here we go. Y minus 45 equals 3.5x minus 99 times 33. 3.5 times 99. And all of a sudden everybody, a million calculators and can't find one. Okay, here we go.
All right, 99
times 3.5. Is
346.5.
346.5. Okay. Now we're going to add 45 to that. So y is going to equal 3.5x minus 301.5. Now, you say, now wait a minute, Mr. Palin. If this is point slope form, if I'm looking at this graph, it looks to me like it's going to cross right at about what? Like if that was 18, 16, right? How in the world are you getting negative 301.5? Okay, well, you have to remember that I've said that I gave this point to be the point 93. So the y-intercept then would be clear back there 100 years ago at 1900, right? So this line would have to keep going down, 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 all the way back till 1900. Okay, so, and in then I know that doesn't make any sense. Obviously there was not negative 301 clusters of woodpeckers in 1900. Okay, but according to our graph, this is not necessarily the y-intercept. So earlier in the video, I kind of paused and I left it like this. One thing that you could have done is maybe you could have said years since 1990. Then I would have made this 2, 3, 4. But when I was making my graph, I did not really consider that. I'll come back and do that in a different problem. Anyway, this equation is still going to work. It's just not quite as fantastic as you'd want it to be. Because the y-intercept doesn't really make any sense. Okay, but let's make a prediction. Okay, the question is, all right, using this equation, the very first one that we're going to talk about is interpolation. Okay, interpolation means we're going to find a year inside of the data, okay? So like we said, okay, if we were using this line, what would this line predict would be the year for 1996? Okay, well, here's how I would do that. I would say, okay, y equals 3.5 times 96 minus 301.5. So this line would guess that in 1996, let's see what we got here. So we're going to go y equals, what is 3.5 times 1996? No, 3.5 just times 96.
336.
336 exactly?
Yep.
Minus 301.5. So this would predict that it would be 336 minus 301.5.
34.5.
So 34.5 in 1996. Well, what was the actual date? The actual data, it was 34, which is actually really close. Okay. Okay, so I can tell I spelled interpolation wrong right there. That should be an R, interpolation. Okay. Now, the next thing that we're going to talk about is we're going to talk about extrapolation. Okay, extrapolation is using points outside of the data. So our equation is pretty dang good for our interpolation. We're, a half a cluster away, and I don't even know if you could have a half a cluster. So that's really good, okay? Extrapolation would be kind of to try to predict the future. Now, I doubt that the active clusters would keep going linearly for the next, what would that be, 20 years, right? The chances of that happening are probably pretty low. At a certain point, the forest isn't going to be able to handle all of them. So at a certain point, you could expect this data to start leveling off. But let's just say that, okay, what if we wanted to find out in how many, if this linear equation or this linear thing kept working, how many active clusters would we have in 2020? Okay, well, how would we do that? Well, we would be looking for the point 2020, and we're going to use this equation right here. So we're going to say y equals 3.5. Now, obviously, the year 1993, we called that as 93. So if we were going to put in 2000 and the year 2000, we would just have to end up calling that 100. So this guy would be 120. Do you see what I mean there? Because 2000, if we call this guy 92, 93, 94, 95, 96, 97, 98, 99, 2000 would be 100. So then clear out here at 2020, that would obviously be 120 for this equation, okay? So 3.5 times 120 minus 300 and 1.5, okay? Tanya, you got that for me? 3.5 times 120?
Sorry, my phone. 3.5 times 120 is 420.
Okay, exactly 420 minus 301.5.
Oh, sorry. 301.5. 118.5.
Okay. If this line were to continue for the next 20 years after this data point, then the prediction would be that you'd have 118.5 active clusters of woodpeckers in 2020. That would be a prediction you could make. Now, the chances of that model being linear all the way out that far, probably not real high, but at least you get the idea. Okay, interpolation, making a prediction with inside the given data. Extrapolation, making a prediction outside the data. So way up here in the year 2020, right? Way out here. Okay, so those are the two different things. Okay, so we've talked about R value, very tightly clustered, interpolation, extrapolation. Okay.